Alright guys, so in this video, we are going to talk about how to place decimals in a product. So for multiplication with decimals, one of the really cool things about multiplying with decimals is that you can use the same strategies that you used for whole numbers with just one extra step at the end. So it doesn't matter if you've been using the box method, partial products, or standard algorithm. Either one of those strategies can be also used for decimals, okay? So probably the easiest way to show you this is to take one problem and show you, after we find this product, how to place the decimals, okay? So notice that in all of these problems, they all have 28 and 34. Okay, 2, 8, 3, 4. So what I first need to do is to actually do the whole numbers, the 28 times 34. So I can do that with any method. I'm going to use the standard algorithm because that's the quickest and most efficient. Okay, 4 times 8, 32. 4 times 2, 8. Plus 3 is 11. Going to the tens place, 3 times 8, 24. 3 times 2 is 6, plus 2 is 8. Okay, so that tells me that for the whole numbers, 28 times 34, my answer is 952. Okay. Well, so for all of these answers, I'm going to have 952 as digits, okay? Because all of the factors have the same digits in them, all right? So now what I need to do is I need to figure out where the decimal goes. All right, because they're not all 952 is the answer. This is whole numbers, okay? So that's a reasonable answer. But when I come down to here, if I were to round 2 and 8/10, I'd round that to 3. So 3 times 34, that would be a 12 and a 10. So this answer has to be closer to 102. Okay, it's definitely not 952. So the really neat part about multiplying with decimals is that to figure out where to place a decimal, you just have to count. Okay, in this factor, the decimal, I start over here on the very right, the very end of the number. Okay, so I start here and I count over. That decimal is one place. This factor doesn't have a decimal. Okay, so 1 plus 0 is 1. Well, that tells me that I start at this side and I go over 1 place. And so here is my decimal. Okay, well, I just proved over here that if I were to estimate 2 and 8/10 times 34, my answer should be somewhere close to 102. Well, look at that. 95 and 2/10. That's pretty close to 102, okay? Now, same is true here. We have the same digits, 28 and 34. So I'm gonna have 9, 5, and 2 in my answer. I'm counting over 1, pardon me, counting over 1. Well, 1 plus 1 is 2. Count over 2 places, and the decimal is 9 and 52/100. Okay, now the way I can prove whether that's reasonable or not, this would be rounded to 3, this would be rounded to 3. 3 times 3 is 9. Look how close that is. Okay, so if you're struggling with where to place a decimal, stop and think about whether it's a reasonable answer. Okay, round, and it'll help you. So let's do this one. So this has one factor that has a decimal, but the other doesn't. Okay, so I start from here and I count over 2. And this one doesn't have any decimals. So that means that the answer here needs to have a decimal 2 places over. Remember, we always start on the right, not on the left, on the right. So 9 and 52 hundredths. Notice these are the same answer. Okay, that's okay, because really we're saying that would be like 3/10, right? Which is really small, times 34. So that makes sense. All right, so then down here we have 2 places and 1. Well, 2 plus 1 is 3. Again, always on the right. 1, 2, 3. Now, if I'm placing a decimal here, I should place a 0 there to tell me that there are no holes. Okay, that this is just a decimal, 952 thousandths. All right, and finally, this last one. So this is over 2. 2. 2 plus 2 is 4. Okay, so if I go here, 1, 2, 3, uh-oh, there's no more. Well, if I add a 0 here, I can go over 1 more place. Okay, so 1, 2, 3, 4. I added that 0 so I could go over. And then I'm going to put another 0 here again to represent that that is the holes. There's nothing in the whole numbers. Okay, so the takeaway from this is the actual multiplying for all of these. If I multiply it like whole numbers, I get this answer. Okay, and then figuring out where to place that decimal point is strictly just counting over. Okay, so let me give you another example. We'll do something that's not up here. Let's say that this time I have 1 7/10, and I want to multiply that by 2 2/10. Okay, I'm just going to forget about those decimal points right now. I will deal with the decimal afterwards. Okay, I'm going to pretend that this is 17 times 22. 2 times 7, 14. 2 times 1 is 2, plus 1 is 3. I'm going to the 10 spot. 2 times 7, 14. 2 times 1, 2, plus 1 is 3. Now add those together. Okay, that's strictly multiplying whole numbers, right? Okay, so I know a lot of students, before you really look at and practice the decimal points, a lot of students look at that and say, oh, the decimal needs to be here. Okay, why do they say that? Okay, yes, because they see that it's lined up. And when we do when we do addition, subtraction, or division of multiplication, that is true. We just line up that decimal. Okay, however, that is not true when we're multiplying. All right, so we do like we did over here. We're going to count over. So start at the right. This one is over 1 place. This one is over 1 place. Well, 1 plus 1 is 2. So I start at the right, 1, 2. So my answer is 3 74 hundredths. Now, I can check that by checking for reasonableness, okay? I can round my factors and multiply and see if it makes sense. So for 1 7/10, I would round that to 2. 2 2/10, I would also round that to 2. Well, 2 times 2 is 4. Is this reasonable? If I were rounding this 3 74 hundredths to the nearest 1, I would round that to 4. So that makes sense. That's reasonable. You always want to double check and make sure that your answer is reasonable, because what if down here I accidentally line them up, okay, instead of counting, and now my decimal is there, okay? Well, if I'm doing this and checking for reasonableness, and I look at this and I go, ooh, 37 4/10, that is nowhere near 4, okay? And I know I did my estimating right, so I know my answer has to be close to that, okay? So then your next thought should be, oh, I probably put the decimal in the wrong place. Let me count again. Oh, that was 1, that was 1, so I need 2. So instead of this being here, I needed to go 1, 2. Oh, 3 74/100 and 4, that's closer, okay? So placing the decimal is really just about counting over, making sure you count both factors if both of them have decimals, okay?